Okay, so we're going to start now, after we've taken that quiz 4A, we're going to start with section 4.3. And we're going to look at different ways that we prove that two triangles are congruent to each other. One of the questions on your quiz was to name the corresponding parts that are congruent. So we had three angles that were congruent to each other, and we had three segments that were congruent to each other. Well, we don't always have to show that all six pieces of the triangle are congruent to each other to have congruent triangles. We have a couple of shortcuts that we can look at today. And the shortcuts that we're going to look at today, there's actually 5 shortcuts altogether. But the 2 shortcuts that we're going to look at today are called SAS and SSS. The SAS stands for side, angle, side. Okay, and that's the first one that we're going to look at. Okay, is SAS. It says suppose you have 2 side lengths and a fixed angle measure in between them. So when I say a fixed angle measure, if that angle measure had to stay at 70 degrees and I gave you 2 specific side lengths that you had to use, there's only one way that you could make a triangle out of that, and that would be to connect those sides. If I had 2 triangles that had those pieces that were all the same, there's only one way to complete that triangle. And so the 2 triangles would have to be congruent to each other. And we call that the side angle side congruence theorem. It says if 2 sides and the included angle, to be the included angle means the angle in between the 2 sides that are congruent. That's the included angle. So if the 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then every part of those triangles are congruent to each other. And you can see an example here. It says identify the pairs of congruent sides.
Students to the main office, Chloe Hamlin, Moria Hamlin, Josh Eilers.
You can see that identify the pairs of congruent sides and angles in these triangles. So you can see that I've got a side that's been marked congruent.
Billy Shepard and Jacob Kelburn to the activities office.
I'm also showing another pair of sides that are congruent to each other, and I'm showing the included angle. So since I have that side angle side combination on both triangles, I know that the 2 triangles are congruent to each other. So side RS is going to be congruent to side XY. I know that segment ST or TS is going to be congruent to segment YZ. And I know that angle S is congruent to angle Y. Those have been marked in the picture. And since I have that combination of side, angle, side, okay, I know that the two triangles are congruent. So I could say triangle RST is congruent to triangle. Since I started with R, I want to make sure that I start with X. And then I went to S, so I'm going to go to Y. And then I'm going to go out to Z. Okay, so because I have that combination of parts, I can say that those 2 triangles are congruent. And I would also know then that the other parts of the triangles are congruent. Because the 2 triangles are congruent, I also then would know that angle R is congruent to angle X. I would know that angle T is congruent to angle Z. Okay? And I would know that, let's see, which side don't I have? RT is congruent to XZ. Okay, I know that those pieces, even though they're not shown in the picture, because the 2 triangles are congruent to each other, all of the parts are congruent to each other. And we say that, let me get rid of this, and the reason that we can say that is down here. It says we abbreviate this property CPCTC. That's going to stand for corresponding parts of congruent triangles are congruent. So once we can know that the 2 triangles are congruent to each other, all of their corresponding parts are congruent to each other. So instead of writing all of that out, we just use that abbreviation CPCTC. Okay, so it says try it. So we go down here and we look at, sorry I got really big on you, we look at 2 rectangles that we're going to cut in half using a diagonal. Here's my diagonal. I want to know if these 2 triangles are congruent to each other. It says, suppose we cut a triangle in half diagonally. Can you show that the result is two congruent triangles because of the side angle side criteria? Therefore that the smaller angles formed are also congruent. Okay, so when we pull apart these triangles, here's triangle BAD, that's down here, and up here is triangle BCD. It says identify the congruent parts of the triangles. Well, we know that since this is a rectangle, we know that we have a right angle in the corners. Okay, so we know that triangle or angle A is congruent to angle C. Also, with opposite sides of triangles being congruent, we know that segment AD is congruent to segment BC. Okay, here's AD and is congruent to BC. And then also opposite sides here would be congruent to each other in a rectangle. Okay, so BA is congruent to segment DC. So we know that those parts are congruent to each other. So since I have side, angle, side combination in both of those triangles, then we know that the two triangles, BAD, that triangle is congruent to DCB. And because the two triangles are congruent, all of their parts are congruent to each other. All the angles that correspond to each other are congruent. It says we can write this argument in a proof. Okay, I want to try to show you the proof and the picture at the same time. Okay, so we're going to start out our proof with the given information. They told us in the directions that we had a rectangle that we were dealing with, so that's given to each other. And if I have a rectangle, that means that opposite sides are congruent. So segment BA is congruent to segment DC. I would mark that in my picture as being congruent. And then also BC is going to be congruent to DA. Okay, and the reason is opposite sides of a rectangle are congruent. We know that's true about every rectangle. Okay, angle A is congruent to angle C. So this down here, these two are congruent to each other. Another thing we could say is that angle A and angle C are right angles, and then we can say they're congruent to each other because all right angles are the same measure. But rectangles contain 4 right angles. Okay, and if I know that, if I list these 3 statements here, I have now been able to mark off the parts, so I can make the statement that the two triangles are congruent. And my reason is that SAS, that's side angle side. And then if two triangles are congruent to each other, then I can state that the angles. So angle CBD, okay, well let's see where angle CBD is. Angle C to B to D. This angle right here is congruent to BDA, BDA. So those two pieces, if you lined up those two triangles, would those two angles line up? And yes, they do. So we can say that they're congruent to each other. I've just said that the triangles are congruent, therefore corresponding parts of congruent triangles are congruent. So that's how we use that SAS criteria in a proof. Okay, now we also have what's called a side-side-side congruence. So if I gave you 3 links, let's say I gave you 3 different sticks of different links and I asked you to see how many different triangles you can form. Well, there would only be one combination that you could form, okay? And so we have, not only do we have the side, angle, side criteria, but we have what's called SSS, and that stands for side, side, side. Okay, so if I see that I have 2 triangles and each side is congruent to another side of the other triangle, if I have 3 pairs of those, then I automatically know that the 2 triangles have to be congruent to each other. Okay, it says which of these pairs of triangles are congruent and which criterion is satisfied. So when you look at the picture here, I've got tick marks telling me that that's one pair of sides that's congruent. Here's a second pair that's congruent. And here's a third pair that's congruent. So what do I have marked in my picture? I have side, side, side. So yes, those 2 triangles are congruent. And I don't have any letters, so I can't name them in this picture. Okay, in this bottom diagram, I have a side marked, and I have another side marked, and then I have an angle marked. Now, I do have two sides and an angle, but is it in the order of side, angle, side? The angle always has to be included. That means it has to be in between. This angle is not in between the two included sides, so this is a no. We don't have criteria for that. Even though I have the three parts, they're not the correct parts. They have to be in the order of side, angle, side. And I don't have that correct order here. Okay? Up here, when I look at this, I have a side, I have an angle, and I have another pair of sides. And this time that angle is in between the two sides. So yeah, that's side, angle, side. That's the criteria that says yes, those two triangles are congruent to each other. And then my last picture down here, I've got a side, I've got an angle, and I've got side. Is that in the right, those pieces are the right pieces, are they in the right order to use side, angle, side? And hopefully you said yes. We do again have the included angle, that's the angle that's in between the two sides. So that one would work. Okay, and then lastly, we're just going to write a proof again. It says write a two-column proof using the side, side, side criterion to show that, showing that the requested corresponding parts are also congruent. So again, we want to start with the given. That's my first line of the proof. Quadrilateral LMNP has congruent sides as shown. Instead of writing that in here, they just listed what's shown. So LM, segment LM is congruent to segment NP. And they've also shown that segment MN is congruent to segment PL. So instead of writing this out, they took it off the diagram and they wrote that out and said, well, that's given. And then the last line of the proof, if you go back to what we did in our proof packet, the last line of that proof, you're going to write down, we're trying to prove that angle M is congruent to angle P. Okay? Now, here's one that's going to be new for you. It says segment LN is congruent to segment NL. Look at that. Here's NL. Okay? That's the same line. Why is it congruent to itself? Okay? It's part of both triangles. We're trying to show that this top triangle is congruent to this bottom triangle. Well, that side is part of both of them. So we can say that it's congruent to itself, and we call that the reflexive property. It's kind of like looking into the river or a body of water and seeing your reflection back. You have the same thing on both sides. We use that a lot in our proofs. When the two triangles share a side, they're congruent to each other, and the reason is reflexive property, or you could say shared side. Now, once that's the case, now how many sides do I have that are congruent? Well, we have 3. So we're going to say we have enough information to say triangle LMN is congruent to triangle. Let's see, we're going to say that's NPL. Okay, make sure your order is correct as far as your letters go. I'd have to take this and I'd have to rotate it over. So this angle over here would be lining up with the L. But once I can say the two triangles are congruent, it's the side, side, side criteria. I've marked off 3 sides in the picture. And once the triangles are congruent, then I can say that any of the parts are congruent. Angle M up here is congruent to angle P. That's a part of the triangle. So my reason is corresponding parts of congruent triangles congruent. Once you determine that the triangles are congruent, then you can say that their parts are congruent by CPCTC. Now, this is difficult, so don't get frustrated. Just keep working at it, and please, please, please show up and join the Zooms so we can talk about it.